you should have this worksheet complete already. Now, we did have this question that was a repeat of the first one. On the first one, because the A value was 1, we did not use an XY table. We used the pattern 1, 1, 2, 4, 3, 9. But I might as well go back to this one and do it one more time just to get you guys warmed up. All right, so you should remember that step 1 on graphing a parabola is to find the vertex. So everybody, step 1 is find the vertex. Don't be lazy. Go ahead and write the word vertex. Write down a coordinate right below it. And we know that a coordinate has an x value and a y value. And we also know to find that vertex in step 1, we need to use a vertex formula. X equals negative b over 2 times a. That's right. So we also know that when we plug in values, I mean, we already know that the a value is 1, the b value is negative 2, the c value is negative 1. We're not even using the c value of negative 1. But when we do plug in those values of a and b, we need to plug them in with parentheses. So the safe thing to do is to rewrite it as negative parentheses over 2 times parentheses. And then plug in your b value, which is negative 2. And then plug in your a value, which is positive 1. And we end up with plus plus up on top. The minus minus changes to plus plus. So we end up with a positive 2 up on top. And 2 times 1 is also positive 2. So we end up with 1, right? X equals 1. That is our x value of the vertex. So up here, I want to put a 1 for my x value of my vertex. I still need the y value. Whenever you have the x value and you need the y value, all you have to do is plug it in and do the math. So we know x equals 1. Here's x. Let's put a 1 right there. Here's x. Let's put a 1 right there. So what I want to do is I want to rewrite this whole quadratic function, y equals x squared minus 2x minus 1, right here on the side. Y equals x squared minus 2x minus 1. And I put parentheses because I am going to be plugging in the value of 1, the x value of 1. And now we're going to use PEMDAS to work this out. And you could use a calculator. I encourage you to use a calculator. 1 squared is 1. 2 times 1 is 2. Don't forget about the minus sign that's between them. Bring down the minus 1, and you have 1, take away 2, take away 1. So if you do that math, your answer will be negative 2. I'm sorry, negative 2. Almost messed up there. 1 take away 2 is negative 1, and negative 1 take away another 1 is negative 2. It's like owing $2. You have $1, you owe 2, you owe 1, you're going to still owe 2. Anyways, that's our y value, right? Y equals negative 2 of our vertex. So here is the y value, negative 2. So we have done step 1. That's barely the first step, finding the vertex. Okay. So finding the vertex, if you don't find the right vertex, everything else is going to be wrong. Okay. So the vertex is the most important point of the parabola. It's the most important point, or most important part of graphing a parabola. If you mess up on this vertex, everything else is going to go bad. So anyways, let's do step 2. If you look at your notes, step 2 is to plot the vertex and draw your axis of symmetry. So let's plot the vertex, 1 on the x, negative 2 on the y, and we're right here. And I always, on my videos, draw my axis of symmetry as a dotted line going right through that vertex, and I always use the color green. And it's good to label it axis of, you could abbreviate, symmetry. Now, we need more points. Yesterday, we learned about the a value, how it controls the width or the narrowness of a parabola. And we know that any a value of 1 is going to have the pattern 1, 1, 2, 4, 3, 9. But instead of using the pattern, let's practice using the old method, the XY table. So when we use an XY table, we want to plug in values. You don't want to just plug in any number. Like, you don't want to plug in negative 4. Why not negative 4? Because if you plug in negative 4, that's way over here on the x. And if your vertex is here and you plug in negative 4, you're probably going to get a point that's way off the graph. So the idea is pick values that are close to your axis of symmetry, that are close to your vertex x value. Pick them that are close and that are on the same side. So which values would be good to pick if your axis of symmetry is at the x value of 1? Well, give me two numbers that are close to 1 that are on the same side of 1. 2 and 3. So it'd be a good idea to plug in 2 and plug in 3. Or it would also be a good idea to plug in 0 and plug in -1. It's totally up to you, right? I mean, you could technically plug in -1, 0, and +1, and +2 and +3, but that would be pointless because the reflection line, once you have two of them, you could just map them over. So, I don't know, which values do you want to use? 2 and 3. Sure, let's keep them positive. So when I plug in 2, let's do this together. I don't recommend doing this in your head. I would write it on a piece of paper or use a calculator. In parentheses, 2 squared. What's 2 squared? 4. Okay, and what's 2 times 2? 2 times 2? 4. What is 4 take away 4? 0. What's 0 take away 1? -1. So when I plug in a 2, I get out a -1. Let's plot that coordinate. 2 on the x, -1 on the y. There it is in blue. Now let's plug in a 3. Like I said, I wouldn't recommend doing this in your head. Use a calculator or write it down on a separate, or wherever you have space. I don't have space, so we're doing this together right here in our heads. What's 3 squared? 9. What's 2 times 3? 6. What's 9 take away 6? What's 3 take away 1? 2. So when I plug in a 3, I get out a 2. And let's plug in that 3, 2 coordinate, or let's graph it. 1, 2, 3, 1, 2. It's right here. And of course, with that axis of symmetry, you could map it over to the other side. So if it's 1 unit away from the reflection axis of symmetry, reflect it over 1 unit away, and you'll get to that coordinate right there. The other one's 2 units away, so go 2 units away and get to that coordinate right there. And that's already a good enough parabola. That's a perfect parabola. Just put some arrows on it because it does continue to go up forever. Now, I did say if your a value is 1, which the a value is 1 right here, if the a value is 1, you could use the pattern from the vertex 1, 1, 2, 4, 3, 9. Those are not coordinates, but check it out. From the vertex, I could go 1 over and 1 up. Why am I going up? Because it's +1. So 1 over, 1 up. And then I could go back to the vertex and go 2 over, 4 up. Then I could go back to the vertex and go 3 over, 1, 2, 3, 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm off the graph by 2 units. But my point is, you could use an XY table if you like XY tables. Or if your a value is 1, you could use a pattern 1, 1, 2, 4, 3, 9. Or both. I don't know. It's just whatever you feel more comfortable with. So I hope we've graphed every single one on this homework assignment. Now, there's more than just graphing. If you read the instructions, it says, please find the vertex. Okay, we definitely did that. Let me actually find the vertex. We definitely did that. The axis of symmetry, we did that. As a matter of fact, we always draw in green on this video. And also find the Y-intercept. Y-intercept. So that's something we haven't been touching on lately, but we have found the Y-intercept in the past. Do you guys remember how to find the Y-intercept when we graphed lines? To find the Y-intercept, you set x equal to 0. To find the x-intercept, you set y equal to 0. Remember that stuff? Yeah? So if they're asking for the Y-intercept, and they are asking for it, and they will ask for it on the final, let's go to question 1, whether it's the one that we just did or the one from yesterday. It's the same one. Let's write down y-int. Let's write it down somewhere. And where does this parabola cross the y-axis? At -1. So the y-intercept, let's put down y-intercept is -1. That's an answer. Box it in, circle it. I don't know, whatever you want to do, just so we could see that answer there. Or you could have written it as a coordinate, y-int 0, -1, right? Whatever you want. You could either just say the y-intercept is -1, or y-intercept is the coordinate 0, -1. So on all of these, we need to state the y-intercept, okay? And you could even state the y-intercept before graphing. Check this out. Let me go to number 2, and let me zoom in so you don't see the actual graph, okay? If I wanted to find the y-intercept of number 2 right here, all I have to do is set x equal to 0. That's what you need to do to find the y-intercept. So you guys see how the x is here? If I put a 0 right here, what's the whole answer going to be? It's going to be 3. So the y-intercept is super easy. The y-intercept, y-int equals 3. It's super easy because all you got to do is set x equal to 0. It's something that we learned a long time ago when we were graphing lines. How do you find the y-intercept? You set x equal to 0 and solve. So, I mean, yeah, if you already have it graphed, like right here, number 2, I already have it graphed, you could actually see where this parabola crosses the y-axis. Boom, right there, it crosses at 3. But I don't need the graph to be able to state the y-intercept. Okay, I could just set the x equal to 0 and solve, and I'll get the c value. As a matter of fact, any standard form quadratic trinomial, when you find the y-intercept, when you set x equal to 0, your answer will be the c value. Any standard form quadratic trinomial. So right here, check this one out. Let's look at this without looking at the graph.
5.
Yeah, it's going to be 5. The y-intercept is 5. Right? It's a standard form quadratic trinomial. If I were to set my x is equal to 0, my y-intercept is going to be 5. So I could somewhere write y-int is 5. The y-intercept is 5. Now, if you look at the graph, you'll see that it does cross the y-axis at 5. The vertex is way down here, and it crosses the y-axis way up here at the y value of 5. Okay? So algebraically, it's a piece of cake to find the y-intercept. Visually, all you got to do is look at it and see where it crosses the y-axis. So y-intercepts are really easy to do. Make sure you understand, not blank out when I ask you to find the y-intercept. I mean, check this one out. Let's look at this. Look at the graph. What's the y-intercept there? Could somebody tell me the y-intercept? -3. Now, what if we didn't have the graph and we just looked at the original function and I wanted the y-intercept? Remember, you need to set x equal to 0. Check this out. Let me write it one more time. Y-intercept, you set x equal to 0. That's what you do. So if you were to set this guy and this guy equal to 0, then this whole thing becomes 0, and 0 minus 3 is going to be your y-intercept, -3. Okay, so the y-intercept, the algebraic way of finding it is easy because it's always going to be your c value when it's in standard form. If it's not, then you actually have to do the math, set x equal to 0, and work it out and see what you get for your c value. For your y-intercept. So y-intercept's cake. I don't want to spend any more time than what I've already done right there, but there's more things that we need to talk about, more things that we need to be able to state. It says, then state the domain and the range of the following parabolas. So we definitely need to state the domain and the range. Now, I hope we remember, and in case you forgot, you might want to go to the top part of your paper, and let's write this down. So these notes are on the board. It says the domain are your x values. All right, the domain are your x values. We should know that. And the range are your y values. Okay, so domain are your x's, they're your inputs. The range are your y values, they're your outputs. Now there's a couple of important facts, especially with regards to domain when it comes to parabolas. The domain values are your x values, and on any parabola, the domain will always be x equals all real numbers. And the notation for that is like this. You put D standing for domain, and then you put x equals, you could write out the words all real numbers, or you could do an R with 2 sticks like that. It's up to you, all right? So let's go back to a problem here, and let's understand why the domain, and this is the way we're going to write it, D, and we're going to put x equals all real numbers. That's your answer for the domain. Everybody needs to write that down somewhere on your parabolas. And guess what? That's the same answer for every single domain on any parabola. It doesn't matter if it's wide, if it's narrow, if it's opening up or opening down, if the vertex is at the origin or somewhere else. It doesn't matter. All parabolas have a domain of x equals all real numbers. Now think about it. If you're thinking about the xy table, the domain are your x values, right? So what numbers could you plug in to x right there and right there? What numbers could you plug in? Any numbers you want. You could plug in 5. You could plug in 5,000. You could plug in 1.5. You could plug in 3.14. I mean, you could plug in any numbers you want. That's why the x values You could plug in any number you want. That's why the x values is all real numbers. You could plug in any number you want. Let's take a look at that visually though, okay? What does it mean, the x values of this parabola visually? Does this parabola exist, here's the x-axis, right? Does this parabola exist at the x value of 0? Yeah, it's right there, at the x value of 0, correct? Does this parabola exist at the x value of -1? Yes. Does it exist at -4, at -2? It actually does, because the arrow keeps going up and eventually it'll probably be right there, right? At -2. Does it exist at -3? Yeah, it'll be way up there. Does it exist at -4? Yeah. Does it exist at -10? Yeah, it's just going to be way up there. So that's why the domain is all real numbers. Does that make sense? Visually, you could see it. Even though it looks like it's curving up, it's never gonna go straight up. It's always going to continue to go to the right. Algebraically, you could plug in any number. You could plug in 4, 5, 6. You could plug in 10. If you plug in 10, you're going to be way out here, which means you're going to go way up there. It'll exist. It's just off your graph, but it's there. Okay? So that's why domain is all real numbers. Now let me ask you this. The range, the R, they're your y values, right? So does this parabola exist at +3 on the y? Yeah, it's right there and right there. Make sense? Does it exist at +5? Yeah, it's right here and right here, right? Does this parabola exist at -1? What do you guys say? Here's -1. Does it exist at -1? Yeah, at these two locations. Does it exist at -2? Yeah, right here at the vertex. Does the parabola exist at y equals -3? It does not. You guys following me? The parabola is not at -3. It's not at -4. It's nowhere below that. So we need to state the range. We need to state where this parabola is with regards to y values. And let me tell you this. On our notes, it says that it's either going to be above or below your vertex y value. And of course, you have to include it. So what's the vertex y value right here? What's the vertex y value? How low does this parabola go? It goes from 5, 4, 3, 2, 1, 0, -1, -2, and then it goes back up. So it goes all the way down to -2, but then it goes back up. So this whole thing, the range has to be, your y's have to be greater than or equal to -2. Everybody please write that down. Y is greater than or equal to -2. Does that make sense? So the domain, it's going to be all real numbers all the time. Why? Because the parabola goes to the left forever, it goes to the right forever. But the parabola is only above this value. You see the line y equals -2? It touches that line, but then it goes back up. It doesn't exist down here. It only exists above this green line. So how do we explain that the parabola is above the y value of -2, but it actually touches it, it's including it? We're going to say y is greater than or equal to -2. So many students struggle with this, but it's not difficult to understand. You just gotta look at it, understand that the parabola is above a certain value, and it's always greater than or equal to or less than or equal to the y value of your vertex. So let's go back to the notes I have on the board right here. That's what it says. The range of your y values, it will always be above or below the vertex y value, including the vertex y value. And I give you an example. I don't even draw it, all right? I don't even draw it. I say the vertex is 2, -3. I mean, you could imagine that. You go 2 on the x, -1, 2, 3 on the y, and there's your dot, okay? And then it says that the a value is negative. What does that mean? Is the parabola going to open up or is it going to open down? It's going to open down because the a value is negative. Make sense? So if I know it's negative, I mean, I could do a quick sketch like this, just draw a parabola opening down. It's kind of negative. I could now state the range. The range is at and below the vertex y value. What's the vertex y value? The vertex y value is -3. So we know that it has to be at the y value -3 and below the y value -3 because it's opening down, which means that the range is y is less than or equal to negative 3. Now, if the a value would have been positive, it would have been opening up. Then I would have said y is greater than or equal to negative 3. Does that make sense? I hope so. Let's take a look at let's see, pick one out of all these that we've done. Let's look at number 3 here. Sure. So we already know the axis of symmetry. By the way, if they ask you to state the equation of this vertical line, all you do is say x equals, and whatever the value is, x equals 2. That's the axis of symmetry equation, x equals 2. But if they ask us for our domain, what's our domain of this parabola that we already have graphed? What's a domain? Come on, guys. What does it say up there? The domain will always be x equals all real numbers. So you need to write d colon x equals that funky looking r with 2 sticks. That's one answer right there. How about the range? The range is going to be the y values. Where's this graph at? Is it above a certain value or below a certain value? But remember to include it. It's above a certain value. What's that certain value? The negative 3, the y value of your vertex. So we're going to say the range is above, which means greater than, and we're going to include that negative 3 that our vertex is at. So that's our answer for range. How about our y-intercept? If they ask us for our y-intercept, what's our y-intercept? Positive 5. There you go, positive 5. Y-intercept's positive 5. Simply your c value of your standard form quadratic trinomial equation. So in addition to graphing, which we need to be able to do, but in addition to graphing, we need to state all these other truths about the graph. Like, what's the domain? The domain's always x equals all real numbers on parabolas because they always go to the left and to the right forever. The range, it's either above or below your vertex y value. And make sure you include that vertex y value because it's a part of the graph. And the y-intercept, you simply set x equal to 0, giving you the c value as your y-intercept value. Those are all the extra details that we need to answer besides graphing. Okay? Let's do one more. This guy right here. Number 3. Could somebody tell me the y-intercept?
2.
The y-intercept is 2. That's right. Positive 2. Yeah. Now you could write it as y-intercept is 2. You could write it as a coordinate 0, 2. And we got that from algebraically just seeing the c value, or even visually we could see that the parabola crosses the y-axis right here at the value of 2. All right, so we have that down. How about domain, guys? What about domain? Domain, you got to say x equals, though. X equals all real numbers, okay? If you don't put the x equals, then you don't get full credit, right? So domain, x equals all real numbers. How about the range? The range, y is what? It's either above or below a certain value. What do you guys say? Is this parabola above a certain value or below a certain value?
Above.
It's below. You see how it's pointing down? What value is it below?
3.
It actually touches the vertex y value. What's the vertex y value?
2.
Ladies and gentlemen, what is this vertex right here? It's a coordinate -1, 5, isn't it? So our range is going to be at the y value of 5 and below the y value of 5. I mean, think about it. This parabola, it's going up, it's going up, it's going up. It reaches that maximum height 5 and then it comes back down. So where's this parabola at? It's right here. It's below that value of 5. It's below. It's not up here. It's not above 5. It's below 5. So what are we going to write as the range? Y is less than or equal to 5. So those are all the extra details that we need to state on our parabolas in addition to graphing them correctly. Do we understand? I hope this video helps you guys. The domain, x equals all real numbers. The range, it's always either above or below your vertex y value. But you got to include that vertex y value. And what I mean by include it, you got to put the or equal to. Should we try one more on the range? Might as well, right? Might as well. All right, how about this guy? Number 2. I'm not even looking at the equation. All right, I'll look at the equation. So let's just state a couple of facts here. The domain is what? X equals, come on people, domain? All real numbers. X equals all real numbers. How about range? Y is what?
Greater or less
it's above, greater than or equal to what? Yeah, what's the y value of your vertex? -3. There you go. We got it. -3. So the domain's x equals all real numbers. Why? Because the parabola does go to the left and to the right forever. And the range, the y values, it's all above this y value of -3 on the vertex. So y is greater than or equal to -3. If it was opening down, it'd be y is less than or equal to -3. But the range will always be either above or below the vertex y value, and you have to include it by putting the or equal to. What other thing could I ask? Y-intercept. What's the y-intercept right here? -3. You could just look at the c value, and you'll know your y-intercept. Or you could visually see where it crosses. This parabola crosses the y-axis at -3. And that's it, guys. I hope this video helps. It's a long one.